Hi, my name is Rowen. I go to Telluride High School.
My name is Nate Ives. I go to Telluride High School as well.
My name is Rhys. I also go to Telluride High School.
And over the course of the summer, in alternative to a traditional internship, we did a project here in Telluride, which was an autonomous satellite tracker.
So our project was pretty much a self-guided project based on the work of a guy named Elwood Downey who lives in Arizona. His passion project has to do with radios and satellites. And so essentially we worked with Zach Nunn, a Stanford engineering graduate, to create an autonomous satellite tracker that follows CubeSats throughout the sky as they move in orbit. And actually some previous Pinterns had worked on putting CubeSats into orbit, and so it's kind of cool because they were on the top end of that and we're on the bottom, potentially tracking those devices.
A little background on CubeSats. They're little tiny satellites that generally universities launch up into low Earth orbit.
Yep. So the premise is when satellites fly overhead, they are always broadcasting a weak radio signal back down to Earth. And this can be picked up by anyone who has the correct antenna and knows the frequency. But because these signals are so weak, a directional antenna is needed to amplify the signal in that one direction. And so while these antennas can be pointed at the satellite by hand, it is much more efficient and much more precise if we had a motor-controlled device that can point our antenna where we need it. And you can know where a satellite is at any time based on widely available data. So on this screen right here, we have an example of the data. On the far section right there is our Keplerian data. This is data based on Johannes Kepler's laws of planetary motion. It includes everything from eccentricity to inclination, and it can be deciphered by software such as this to tell us where any satellite is at any time and where it is in relation to us. Some of the satellite data, our first goal was to receive weather imagery. So on the satellite, there's a camera taking pictures of Earth and broadcasting it back down to Telluride. And these images are sent down either as analog or digital signals and on a few different sets of frequency bands. And because many of these satellites are old, people have already figured out ways to decode the data. But alternatively, on newer satellites, such as the CubeSats put up by universities, this is also data transmitted down on amateur radio frequencies. Some of the radio equipment we used, I'll just go briefly over this. We used a software-defined radio, which is a radio you can plug into your computer, and it'll pick up the entire radio spectrum, and you can see it on your computer. We also used filters to block out unwanted signals, and the software we used, GNU Radio, allows us to do a lot of that virtually in interface software.
For how we actually designed our tracker, we knew we needed to allow the directional antenna to face any direction 360 degrees and have elevation control so it can track it throughout the sky as it goes above us. So how we accomplished this is we decided we were going to build a box that has a 360 degree servo on the bottom attached to a tripod so it can rotate all the way around, and another servo that lifts the directional antenna up and down. See it pointing at the correct azimuth?
So those two directions are called the azimuth, our compass directions, and our elevation, so angle above the horizon.
Here's a few pictures of us. The satellite tracker, the cube that we had holding all of the technology is on the far left side. We laser cut the box with our own little label on it. So some surprising things we learned throughout the process is the guy whose project we were going off of, Elwood Downey, made this project look a lot easier than it actually ended up being. Delivery companies were not as reliable as we had hoped. Those were a lot of our setbacks, having to do with delivery and shipping and products. But regardless, we actually learned a lot of different things. 3D modeling in SolidWorks, which is a pretty standard engineering tool, soldering, laser cutting, and Arduino code. And then some advice for future Pinterns. Even though our year was pretty abnormal, we definitely took advantage of it. Make lots of phone calls, stay connected, involved in your process, and you can really make the best out of any situation.
Yeah, basically people are generally really willing to help you with something they're passionate about. Like, we emailed Elwood Downey because we were stuck on this section, and he really helped us out with that.
Yeah, he emailed us immediately
Yes.
back for help. So,
All right.
and then lots of thank yous.
Thank you.
Thank you.